For this episode, I'm doing something a little different. Rather than just kind of explaining what I've done previously since the last update, I'm actually going to do a deep dive into tackling a specific issue and try to just document how I worked through it. So for this episode, I'm focused on the energy system for the fish population, which up to this point I'd kind of thrown together. I'd thrown some numbers in there, but I didn't feel like that the numbers were very reflective of what they should be. I needed to check to be sure that the energy from plants was related to the energy from eating meat. I needed to figure out the energy usage of the fish living. What did their swimming energy use look like compared to just their being alive energy use? So that's what this video is about. I realized I needed to really dig into my energy system. I threw it together pretty quick and easy just to be sure it worked, but I didn't really work out much of the details yet. Up to this point, I needed to check it to be sure that it kind of made sense. So what you'll see on the screen is my use energy method, which is part of my fish script. And this script gets called, I think it's on a invoke repeating loop where it gets called just every 1 second. I figured that's sufficient to calculate all this. Once a second is probably fine. And I can always change how fast energy is used up by affecting these two scale numbers right here. Energy used per mass and energy used per velocity. So I can change those static variables, and that'll increase or decrease the amount of energy used per second or per call to this method. So to debug this, I put essentially some print screens here. So it's going to print to the console some information. It's going to show me the first part here is the amount of energy that the fish uses just for being alive. That's called living, and it's the mass times energy used per mass divided by the simulation speed slowdown factor. So that's that time slider that I have in the simulation. That's how that is factored in. So that's the just for being alive part, and there's energy used here for swimming. And it's if the swimming velocity is 0, then there's no energy used here. But if the swimming velocity is greater than 0, then the energy used is scaled by the amount of the velocity. So I wanted to print both of those out to the console so I could see it happening in live in time to be sure that the numbers looked reasonable. What happens is once the energy used is calculated right here per second, then the energy of the fish is reduced by the energy used. And then I do a little note here where the total fish energy used in the whole system, that global variable, is reduced by the energy used by this one fish. By that way I can keep track of the total energy of all the fish in the system at once, because every time each fish loses energy, it reduces it by whatever that amount is per fish. So I should point out that this script here is attached to every fish. So every fish is doing the same thing in terms of figuring out its energy, reducing it from the total energy. There's a different script where it adds energy when the fish eats something. So that doesn't happen here. This is just using energy. And then I check right here to see if the energy is less than 0, then the fish is going to be dead. So then I do a kill fish script where I destroy the fish script. The fish object is turned into a dead fish object, which breaks apart into the meat objects. And the last thing I have here is a cap. I don't want a fish to be capable of infinite amount of energy. So they can hold a maximum amount of energy within their body, and that's set by this max energy global variable. And then that variable also then is tied into the size of the fish. So this rigid body mass is where I have that. Rigid body mass is essentially, though, not really the mass of the fish. It's really essentially the area of the fish. So it's really the width of the fish times the length of the fish. All right, so sorry that was a long explanation, but I kind of wanted to show how you might debug something like this and test to be sure the numbers make sense. We're going to print to the console and see what kind of results we get. Okay, so back in Unity, to test this, I've got to be careful here. If I ran it with 50 fish, I'm going to see 50 fish printing their energies to the console every second. So to get a real good test for this, I've reduced the initial fish count in the global variables here down to 1. And I've set the speed to full speed, which is 1. And I'll hit play here. We should get 1 fish swimming around in the ocean. Okay, we got a fish there swimming at full speed. And I want to test not only at full speed, but I want to see how is it going to do energy-wise if I slow down to the slowest speed on the time scale, which essentially is 1/4 the speed of full speed, which is actually more like a realistic kind of fish swimming speed. And now let's look at the console and see what kind of numbers we're getting. Okay, so looking at our console here, we started the simulation at full speed, and you'll notice the numbers here that we see. We see the living amount of energy. It's only taking off 0.1 energy per second, but in terms of the movement, the velocity, it's taking off 4. So we're talking like 40 times, even more than 40 times the amount of energy for swimming as opposed to just living. That's clearly not a good scale. I don't know how it is for human beings. Our body uses a certain amount of energy when we're just sitting still, and then our body's burning up more energy if we're being active, like if we're walking, or even more energy if we're running. So what about a fish? A fish just laying there doing nothing burns a certain amount of energy, but a fish swimming burns up more energy, and a fish swimming as fast as it can go will burn up the most energy possible. So I'm thinking maybe we'll have a fish will burn up maybe, let's say a fish will burn up 1 energy unit per second just for being alive. Maybe it should burn up 3 energy units if it's swimming at full speed. So maybe then it will only be burning up 2 energy units if it's swimming at a moderate speed. So anyway, let's look at the numbers here. So obviously I've got to fix the scale here, and I can do that by changing the energy used per mass and the energy used per velocity in the global variables. Now let's slide down and look at the numbers we got after we slowed this thing down, and you'll notice the numbers dropped from I forget what the first one was here, the living number, but the moving energy usage dropped from 4.2 down to 1. So pretty much dropped it down by 1/4, which is what I would hope for and should expect if I'm going from full speed to 1/4 speed. That's what the time scale slider does. And yeah, the same thing is true there. This was 0.1, wasn't it? And now it's 0.025 essentially. So imagine it went from 0.100 to 0.25 essentially. So the time scale is working, and it's affecting the energy usage for both of those appropriately. But the energy usage is way off in terms of the thing is not getting hardly any energy usage from just being alive. It's all just swimming. So I'm going to have to bump up the energy that's used up per living, or pull down the scale for the energy use per velocity. What I really need to do is look to see how much energy is being gained from each bite of a piece of plant, and then kind of use that as a guesstimate, I think, as to how much I want to have used per second here. So I think I misspoke earlier that there is an add energy script in the fish script, or an add energy method. But this method is called by the gullet script, which is for the mouth. When the mouth hits a food object and takes a bite, then it will call this script, and it will actually send the amount of energy it should add in this parameter right here. So I've put in a logging statement here to log how much energy is added, so we can watch the console and see when that fish eats, takes a bite of a plant, how much energy is being added per bite. You can see here, just similar to the other, here we're adding the energy added to the energy. For the total energy of the system, we're adding the amount of that single bite by that single fish to the total energy of the fish. And we're also checking here. What are we checking here? Oh yeah, we're checking to be sure that the energy is not going to be greater than the max energy allowed for that fish. For a fish of that size, of that area. So we're actually calculating if it is over that. We're going to reduce the energy down to the max energy level, but we're also going to fix the fact that we added too much energy to the total population here. Because if we're going to reduce it down here, we need to also reduce it by the same amount down here. So that's what that script does. So let's see what this what these bites add in energy to the fish. Okay, back in Unity, I'm going to, I've still got a single fish. I'm going to put some more plants in there, so we're going to be able to eat some bites of plant more quickly. So let's have 20 initial plants, and they're going to grow to a max of 200. So we're going to get some nice big seaweeds here, I think. So let's give it a go. Alright, so I skimmed through the console data to look to see what the bite values were, and I didn't see any. And then I realized I had forgotten to save the fish script when I added the debugging line to it. So I saved the script, Unity recompiled. So let's start over and try this whole thing again. Alright, there's our fish, full speed. There he ate some ate some plants at full speed. Let's see if he can eat some plants at 1/4 the speed. Okay, yeah, some plants there. All right, so let's take a look at that. All right, so here's a nice example of what's going on. This is still at full speed, like we saw before. These numbers were what we saw before. Must be about the same size fish as we saw before. And notice that the energy added, here we have an energy added. This is one bite right here. It added 0.8 units of energy per bite, and then right below it is another bite. So taking 2 bites of, I'm not sure if those are 2 different plants or 2 bites of the same plant as it was swimming over it. Not sure. But so that's interesting to note that the energy from that bite is pretty much 1. And compare that to per second, it's losing 4 units of energy per second from just swimming full speed. So I'll have to figure out how we like the comparison of that, how that ratio of energy used per swimming full speed compares to the energy gained from each bite of a plant. And keep in mind, if it were eating a piece of meat from a dead fish, the energy would be basically twice this. In our test here, remember I slid it down to the slowest speed, which it really is 1/4 the max speed. So at 1/4 speed, we have what you notice the value here went from 4 down to 1. That makes sense. The velocity went from 40 something down to 10. Notice the bites per the energy per bite is still 0.86. But that makes sense because the amount of energy they get from a plant is the same no matter how fast or slow they might eat it. The difference being at the 1/4 speed, the fish is swimming slower, coming in contact probably with fewer plants, can take fewer bites. So I think that looks okay. So we'll just have to figure out how I want to scale the energy used velocity versus just living. Moving energy used versus living energy used. Okay, so I like to use Excel to help me figure out what kind of my parameters should be. Help me do my math instead of using paper and pencil and a calculator. Just do it on here. So you'll notice I've got a bunch of different tabs down here that I've used for different things. Fin angles, plant growth, moving averages. That's for the energy moving average over 10 seconds, say. Max velocity tab, fish size tab. I just created this one called energy tab to help me figure out the energy. So basically, energy is being used by every second. Just for the fish being alive, essentially a fish at rest energy amount, and a fish swimming at maximum speed is kind of what I've got in the simulation right now. So right here are the numbers that we just measured in our little experiment of what the energy was being used per second at 1/4 speed. I think my desire is to have more of a situation like this, where the swimming at maximum speed is essentially tripling the amount of energy that that fish is using per second. If he's swimming slower, that number is going to be quite a bit decreased. So, but these numbers are too big. I kind of like the fact that this fish is using up about 1 energy unit per second, given the fact that when he takes a bite of a plant, he's eating 1 energy unit per bite. So if he can eat a bite of plant once per second, he's going to stay alive. So maybe we'll need a lot of plants that way. So maybe that's not enough. Not enough. We'll see. Let me think about that. But so let's say we want, instead, the current energy used, we want that to be, let's say, 2. We want, if we're going to go from 3, where this is 2/3 of that, and this is 1/3 of that, let's actually put that as a formula in. So we'll put that formula in. We want the living, if a fish is swimming at full speed, we want the moving energy is going to be equal to 2/3 times the total energy. Okay, good. And we'll do the same thing here. This is going to equal to 1/3 times the total energy. Okay, so we change this total energy. Say we want it to use, let's say, 0.5 units of energy per second instead of, that's essentially half what it's currently using. So we don't have to eat so much fish. Then that tells us that we want the moving energy to be 0.33, and we want the desired energy to be just for being alive will be essentially half of that. Okay, so what's in the orange cells here? I wanted to figure out how Unity was calculating these values for the energy in our experiment. So starting at those and the formulas that are used to calculate those, given the fact that the sim speed was set down to a quarter speed, and the experiment told us that the velocity of the fish at that point was 10.17, and given the fact that the global scalars for both resting energy used per second per unit and swimming per max was also 0.01. Basically, these are our global scalars that we have that we can change. We're going to change these values to try to turn these values that we got from the experiment into what we want them to be, 0.17 and 0.33. So, so keeping the mass the same, the constant, everything the same, these numbers we can change right here. So this number needs to be bigger. So we could just play around with it here and see what works. Okay, so it looks like it's going to be pretty close to that, right? 0.065, 0.066, 0.064. That gets down to 0.1666 repeating, which is what this is. That's good. And for the for the swimming energy usage, this number needs to be 0.3 instead of 1, so it needs to be smaller. So 0.005. Okay, it's better. Getting closer to 0.033. I could do the algebra to figure this out, but why not just experiment and get it experimentally here to get something close? That's pretty close. 0.0035. Wow, maybe it's almost 0.33. So that makes sense actually. Wow, real close. This is interesting that the scalar is essentially, I mean, you double 32 and you get 64, but we're decimal place over, so it's like this number here is 20 times that number. So that's kind of an interesting coincidence, I suppose. So let's try putting these numbers in, run our experiment again, and for the global parameters, change them from what they were to these, run the experiment again, and see if our energy is coming out more like we hope for it to here. So for our global variables, notice right here I've changed our values to match what we figured out on our spreadsheet. So we're going to run the experiment now and see what our energy usage looks like per second. Okay, this fish is a lot smaller, so that's going to change the numbers a fair bit. I like to do the clear on play when I'm testing things like this. So every time I hit play, it's going to clear that junk out of the console so I can start fresh every time. Let's see if you can eat a plant there. I think he got to eat a plant. Here, you eat another plant. All right, let's take a look at that. Okay, so here we see he took a bite of a fish. Notice the energy added here was 0.5 instead of almost 1. But this is a smaller fish. He's got a smaller mouth. He takes smaller bites, so he gets more. He has less energy per bite. Notice his magnitude is also 6 instead of 10, almost 7 instead of 10. So he's slower because he's smaller. He's fish. He's shorter. So his maximum speed is less. So his velocity is less. So he's going to burn off less energy. So notice the so that kind of explains the numbers right here. For our living, we have 0.03. For our velocity, for our movement, we have essentially 0.045. So it's they're a little closer together than I wanted them to be. I was hoping this number would be about twice this number. I think if the velocity was higher, if the fish was bigger, I think that would probably be the case. But I can always tweak the numbers a little bit here. Right now, the factor we have set for this one is really 20 times the size for this one. Maybe I should experiment, try making it 10 or 15. But anyway, I think that's enough of this video though for now. We've gone deep into the woods and on this one, deep into the weeds, I should say. And but I thought it might be interesting to kind of really show the nitty gritty for like how to like in a sense debug these things. Just really seeing how the parameters that I've set up, are they working like I want them to, for one, in the code, and then if they are, then trying to figure out what are reasonable parameter settings to set in my global variables so I get some kind of reasonable behavior out of the simulation. So that's one of the fun parts about the project, I think, is trying to make this world and make it so it works and put the parameters so it works. So as I've thought about doing this, what might make this a fun kind of an application that other people might want to mess with is make these parameters available not just in Unity to the developer, but make them available to the user, so they can so you could like set all the different values you want and see what kind of world it produces. You could try giant plants, you could try tiny fish or large fish or tiny fish. Have a big range from really tiny fish to super huge fish, all by changing these parameters. How fast the plants grow, all these things are accessible here by the global parameters. So that's kind of how this app is working so far, and might make for a fun kind of game of sorts, where you're not just watching the hard-coded parameters that I decide are best, but a user could actually change them. So anyway, that's a long ways down the road. Anyway, if you've watched this far on this video, you're doing pretty. I'm pretty appreciative. So I hope at this point you've. I guess that means you found it a little bit interesting. So thanks for watching. All right, so I did a little more experimenting on these scalar numbers right here, and I've increased both of them from what they were experimentally, but I feel pretty good about these numbers right here. Notice if you look at our numbers here, the living energy is about half of what the movement energy is costing with this thing swimming at full speed. So that seems pretty reasonable, and this is pretty close to what we had before, where the top scale number here is almost 20 times the other one. In this case, it's 18 times. So maybe the key here is for me to like have these numbers in approximately a 18-to-1 kind of ratio, and then I can always reduce these, both of them, keep that ratio if I feel like the fish is burning through their energy too fast. So that's it. Really going to end the video here. So thanks again for watching.